we have gone very far to search for another prominent individual in our field. She's Professor Eucharia Nwaichi. Over to you. You have the floor, Prof.
We go straight to the business of this evening, ensuring consistency in scientific terminologies, units, and measurements. That's why we're here today. And something is unique among all of us. We are researchers, just people who are seeking knowledge to up the existing knowledge, to bring new dimension, or to completely innovate, bring something new on the table, or new ways of appreciating existing knowledge. This is all we do. So there is every need that we think about ensuring consistency in the terminologies that we often encounter, units and measurements. So why standardization matter? We'll think about this using this guideline, departure, importance of consistency in scientific writing, key international bodies, strategies for consistency, units and measurements, and then we draw important conclusion and then recommend following that conclusion. The key message that makes our departure is that scientific progress relies on clarity and uniformity globally. That's the key message that draws us to this topic as we're making a departure. Why? Because lack of standardization of terminologies, of units, and formats would always lead us to misinterpretation, errors, and inefficiencies. And again, scientific discipline, as we are preaching today, the good news of interdisciplinary approach to researching and multidisciplinary approach as well. We need to speak common language. We need to have common units. We need to have common measurements and common frameworks to deliver in our research enterprise. So enhancing reproducibility, comparability, interoperability, which is our target as researchers, will be very good. So to bring this to see how we need to develop one universal standard that covers everyone's use cases, we will consider some case studies. And the very first one we are considering here is that of the NASA. Of course, we know what NASA is. The National Aeronautics and Space Administration is an agency in the United States. So we have a very blown case. We call the NASA's Mars Climate Orbiter disaster. So what happened? NASA lost about 125 million US dollars. Mars Climate Orbiter, you know what orbiter is? Like a spacecraft revolving around the planet. So because of a failure in unit conversion between two teams, two teams, the engineering team use imperial units, not the imperial units used in America, in Liberia, in Myanmar. So these units were deployed by the engineering team to interpret force, pounds, seconds for force. And then the implementation team, which is the navigation team, when they received the engineering team as a guide, they assumed the data was in metrics, which is the Système International unit, the Newton seconds. Crazy, isn't it? It gave an impact. But the impact derives from the inconsistency that the engineering team used imperial units and the navigation team used the metric system. So it made for miscommunication, and the miscommunication led to spacecraft entering the Mars at the wrong altitude. And you know what that is? And then it caused it to burn up and disintegrate. It was a big disaster. So we learned lessons there that standardizing units and ensuring consistency across teams is critical to avoiding costly errors like this one that cost as much as whooping 125 million US dollars. This case strongly reinforces the need for precision and standardization in academic writing, research, publication, and global collaboration. The second case study of the four that we'll be reviewing will hover around medical dosage errors due to unit inconsistency. There are a lot of them that have been reported, but in medical field, I just want to touch one, and then we'll look at the one with glucose as the fourth one. So this one is on medication overdose in pediatrics, dealing with milligrams and micrograms. So in this case, a newborn in a neonatal clinic was accidentally given 1,000 times more dose of morphine, and that gave severity respiratory disease. And it was near fatal consequences that was experienced, but for the experts that were there to handle and rescue the newborn. So the inconsistency was 10 milligram of dose that was interpreted from 10 micrograms. 10 micrograms was prescribed, and the nursing sister now imagine 10 micrograms was 10 milligrams for whatever reason. And that means 1,000 times microgram to give a milligram. So 1,000 overdose, 1,000-fold overdose for the neonate. So it highlights danger and inconsistency in unit usage. And then what was the impact? The infant suffered from opioid toxicity, requiring intensive care from the experts. And this intervention led to preventing fatal respiratory failure, and the child was saved. So we can learn lesson there that consistent and unambiguous use of units in medical and scientific writing is critical. And this case again illustrates why standardization is essential, not only for academic precision, but also for real world safety, as you can see. So we go to the third one. If you look at this image, you see someone wants to give a handshake and another one wants to bow. They want to greet. So that's what we try to do in research. We are heading to same destination, but sometimes intention is not expressed in the same way. So this third case study that we call the Kenobi disaster happened in 1986, April 20, to be precise. It was adjudged to be one of the world's most disastrous environmental and industrial accidents. It will happen in Ukraine. Chernobyl is Ukraine, so it's called the Kenobi disaster. So Chernobyl in Ukraine. A reactor at the nuclear power plant went out of control during a test at low power, and that led to explosion and fire that demolished the whole reactor building and released large amounts of radiation into the atmosphere. So in this Chernobyl disaster or accident, that is adjudged one of the worst, something was very important. It was caused after the investigation, partly due to lack of standardized safety protocols and miscommunication in measurement units, because the inconsistency hovers around different teams using units to express radiation levels. So the first team used Roentgens, which is an older way to express radiation. And then another team used the Soviet and Grays, which is more recent way of expressing radiation. And this caused a lot confusion by the engineers, the medical personnel, and even the authority, the Soviet government, because in the risk assessment, they underrated the capacity of the emission because of these units that were used. So the impact is that 30 deaths were recorded on the spot and thousands of long-term exposure that came down with cancers in a lot of individuals that were exposed to radiation. And so you can see policymakers being misled by our own undoing, unknowingly, when we don't harmonize, when we don't standardize the units of expressing our data that we harvest from research. So we misinform the policymakers and they make policies that would have arrested this in intervention, but there was delay in containment, because looking at the older units, they interpreted the exposure risk to be low risk before they found out thousands of people already came down with cancer, and it continued to count, as we call that the long term. The last case study we'll look at is the misuse of units like the milligram DL millimole per liter in medical studies. So what actually happened? So we found that a clinical study on diabetes management misreported blood glucose level due to inconsistent unit conversions. So of course, in Nigeria, we use millimole per liter. But in the US, in Liberia, in Miami, they use milligram per DL. So that's the inconsistency. So it was mistakenly recorded as 150 millimole per liter because the person recording had the more international, the global method of reporting in the millimole per liter. So instead of the correct 8.3, because you have to use a factor, 1 millimole to be 18 milligram per DL. So it was just lifted that way, 1 milligram per DL to be equal to millimole per liter. So that means the error exaggerated the blood glucose level by 18 times, making the patient appear severely hyperglycemic. That means elevated sugar level to be extreme. And this misled the clinicians into considering inappropriate intervention with insulin, and that caused life-threatening hypoglycemia. So you can see here that the lesson says always specify the units clearly in medical and biochemical research. Use standardized unit reporting, like the millimole per liter for international journals, for international public documents, for policy memos. Use standardized one, except it's agreed. And if it's agreed, everybody should pay attention in the conversion. Double check calculations to see that life-threatening errors is eschewed. So what are the key areas of inconsistency? So we have to deal with the importance of consistency in scientific writing. Just as you see the image there, if you rely on motivation or comfort, what my choice is, I choose to use metric system, or I choose otherwise. So it goes up and down, it has no pattern. But if you rely on consistency, look at the graph, they're beautiful. You can calibrate, determine any value at any point you have chosen. Yeah. So it matters because it ensures clarity, accuracy, and reproducibility. It facilitates interdisciplinary research model that we preach, and international collaboration. Because when we use like the metric system, the system international system of naming units, you see that we can collaborate, they understand what we mean. It happened to me, I didn't use my example. It happened to me in the United States when I was going to measure. Yes, when I was going to measure acid, and then I saw the acid in quarts. Meanwhile, I'm used to mil or liter. So it took me a long time to do the conversion, and they were saying no, I was saying yes, and nobody was sure. So I did a wrong mixture, and then my lab coat prevented my gene from being burnt. I had some burn on the gene, but lab coats absorbed a lot of it. So these are things that will happen when we don't pay attention. So if we're going for terminology, we ensure uniformity in scientific terms. It prevents ambiguity that are associated with everybody come with what you prefer, what you're comfortable with. This is science, this is research space. So we don't want conflicting definition. Using standardized biochemical nomenclature, and whichever field that you practice, the standardized nomenclature, say IUPAC for those of us in chemical sciences, will facilitate interdisciplinary collaboration that we want to have that can help us to win money, the kind of money we need to solve problems using research. You can again see that formatting helps us in standardizing documents in structure, including references, how you want them included, and the type of references style that you are choosing, the heading style. Some person use first level heading, all caps, second level heading, maybe initial cap or something. And next level, maybe italicized. In chapter 1 and chapter 2, they adopt another heading style. This is wrong. For us as researchers, we have to use similar heading styles. Figures, if we want to convert values to figures, we have to be conventional, consistent. We know figures are labeled below the figure. So we have to maintain that when you label above it, like a table, it can communicate a different message. The tables, if we want to represent data in their exact form, like 3, 4 decimal places. The only way we can do that is using tables. We don't use figures at those points. So this way we are standardizing our practice in research, enhancing readability. Even those reading them, readability becomes more appealing, and you see professionalism when they look at the writer style. Adhering, if you're submitting to a journal, to journal-specific guidelines, streamline peer review and publication. Some journals have rejected papers because they fail to adhere to guidelines. Reporting conventions, which is your area and what research type are you carrying out? Following established guidelines will be very helpful. If you, for example, clinical trials, you're going through clinical trials, using consult would be good. So, or Prisma for systematic reviews, if that's your research methodology, or you're doing observational studies, you use Strobe. So these will ensure transparency and reproducibility, because every research we have done must be able to be reproduced. Otherwise, it makes no sense, because people can take off from where you stopped. So promoting credibility and comparability across studies, whether regionally, locally, nationally, or even internationally, we achieve that by doing our reporting in a conventional manner. And also making research findings more universally acceptable and applicable. We want our research to be universally applicable. What I do here, people in America, in Latin America, in the UK, in the Europe, in Asia, they should be able to take up my work and move to the next level. So I want you to, in one word, what does consistency in scientific writing ensure? Yeah, so just go to the chat box and write one word. Good. Credibility. Reproducibility. Brilliant. Whoa. Focus. Constant. Accountability. Uniformity. Fix. So we can see from our feedback, we have clarity, we have accuracy, credibility, fix, reproducibility, uniformity, reliability, precision, coherence, comparability. All of these put together shows that we need to have an international body that will ensure that all of the comparability, all of our clarity, accuracy, that we follow them. That's why we have international bodies. So we have, for example, the ISO, International Organization for Standardization. They are standard setting bodies. We have the IUPAC for us in chemistry. They standardize chemical nomenclature for us. So we can chemicals that are for oxidizing or for reducing action, different classes. In case of storage, we know how to store them. So we don't use chemistry for bad use, but only for good use. So you see the Bureau International, the POIDES, a measure, maintaining SI units, the Systematic International units. You see the International Classification of Diseases by World Health Organization helps us to ensure consistency in medical terminology for those doing medical research. And the IEE, Institute of Electrical and Electronics Engineers, standardizes engineering publications. So that helps us to agree that these organizations create uniformity across scientific disciplines. So that's very important if we must agree and realize all of the words you threw in. These international bodies are there, and we should follow them on social media or wherever they are to know what is new, because sometimes we live where we are and many of us do not know. Yeah, so we need to do that. Yeah, strategies for consistency in scientific writing can be likened to what you have here, using the image we have: fire for sale, cooking fire, heating fire, lighting fire. Product diversification, I like that. Are they really different products? Because this is what we are doing in research. Are they really different products? Yeah, we need to answer. It's not. So just as fires serve different purposes in this image, serving cooking, serving heating, serving lighting, there remains fire. Scientific terminology, units, and formatting should remain consistent across disciplines. Reports and publications should have this consistency to avoid the associated ambiguity. Like fire being repurposed, but still remain fire. Scientific writing should adopt different context while maintaining the consistency for effective communication. So these are strategies that we have suggested we can follow, best practices for researchers and writers are to follow to ensure consistency in scientific writing. So we can do that to avoid non-standard and regional variation. So in this region, Africa, this, in Asia, this, in that, but or even regional. In Nigeria, we also have regions. So all those variations can be eschewed if we follow these strategies. So some of us like to write American English. Some of us like to write British English. We are colonized by the British people. So most times our official language aligns with the British. But sometimes we go for fellowships, for different kinds of interaction. We collaborate with people from the America and we get to learn American English. Or for some, they like how it sounds. It's better for them, or how you write them. They are shorter often. Like color, they remove the U in color. So if we want to write using American, we must maintain American style from beginning to the end. That's why we talk about the style guide. So every organization, every research team must look at the style guide and write, not to mix up things. The style of the writing must be uniform across board. Writing liter. So some will write the British L-I-T-R-E, and some other ones will write the American L-I-T-E-R. In one document, no, there should be consistency as you collaborate with peers. So that's why we have meetings, we discuss, based on our audience, our intended audience of the research, we decide what works that will not place confusion, as we have shown in some case studies, but only will guide us into what we want to achieve. So another one is formatting. I've talked about formatting, so I'm not going to talk a lot about formatting. Constant with terminologies like climate change. I was reading a paper, climate change, some other places, they say global warming, one and the same thing. So in that particular piece of scientific writing, we should maintain global warming, maintain climate change. So you don't confuse the reader or send them to do some action that will not align with intended use when we are doing this. Yeah, so you can also, in collaborating with peers, think about the imperial or the metric system. I talked about measuring volume, weight, milliliter and liter that I'm used to, which is more conventional for global audience. But some are still using ounce, pound, so tons for weight instead of milligram, kilograms, grams. So how do you compare across board? You go to take our blood and they tell you you need 1 pint. So it means that you need somewhere less than half a liter. That's what it means. But when they say you need 1 pint, some persons may not understand the volume of the blood. So also those in the hospital and similar places should align with what audience would connect with when we are choosing. We need to standardize our science based on what we give out. So I said, example, scientific journal rejecting paper due to inconsistencies. So which strategy do you find most challenging here? Let me ask, which do you find most challenging as a researcher? Is it using established guidelines or adopting système international units and recognized terminologies, or using consistent formatting where you deal with font, heading, citation, and all of that, or cross-check for standardization, or collaborating with peers, ensuring uniformity in co-authored papers, so you don't see chapter 1, you know that Professor Deshope wrote it, and chapter 2, Professor Eucharia wrote it, and another one, maybe Professor Issa. So we can see different characters. One paper is from author, but we don't need to see the different variants in the paper. So which do you struggle with most? Which is more challenging? Let's see what you write in the chat room. 2, how to adopt the Système International unit and recognize the terminologies, you know, that is leading, and then followed by the reference management tool. So you can use reference manager to solve that problem. A lot of people do not know how to use reference manager, the EndNote, the Zotero, and many others that are available now that you can have for free. That can help you for those struggling with number 4. Some of us who are outdated a little bit, we were used to a manual referencing, that now you can use this. After that, you cross-check to see that is correct. They are AI, and so they can't take over our brain. We need to cross-check with that. So I can see great responses. I see that many of you find number 2 more challenging. And he highlights why consistency is key in scientific writing to ensure clarity, credibility, and easier collaboration. So if you're struggling with number 2, remember that tools exist to check your SI units, whether you're using the metric style or you're using the ancient American style. But Americans do not want to give up their styles, even as the world accepts the metric style, which is more used in Britain and many other European countries, and we also use that. They don't want to give up. So if your audience is American, you can use the American. You can do conversion, pay attention to see that the numbers are right. We just don't want to mislead people. You have seen the fatality and what we have caused using science products when there are inconsistencies or no standardization in output. So that's why we have to keep in mind that we can use tools available to us, and we can spend time to look at the units and look at converting them, and then making sure that terminologies that we use are appropriate in the language register. That when we're using one in fine arts in our medical field, that it still represent what we intended it to use, from fine arts job to medicine. So we need to see that recognized terminologies in the field must be used. So if there are structured templates that can be used, this can be very helpful. So let's keep these strategies in mind as we move forward as researchers, is to really help us. Why standardized units are crucial? Standardized units are very crucial because they help us to prevent misinterpretation and data discrepancies, essential for scientific replication. We talked about replication of what we have done and policy making. We saw where the Soviet government was misled because of unit usage, and then they could not do containment as when needed, and we had long-term cancers. So they are also very crucial because the SI units ensure global uniformity, like I've said before. So instead of using length, inches, feet, yards, some person, they ask them, how tall are you? They are not sure what it is in feet or inch or yard. So, but if we use a millimeter, centimeter, meter, kilometer, so we can quantify length using our SI unit. We can also think about, instead of ounces and pounds, tons of rice. How? What is a ton of rice? So you need to pay attention to converting them to milligrams, kilograms, grams of rice. So how about cups? Some persons say 5 cups. 5 cups of the gunpowder was used. How do you know? We have a lot of cups. How do you know which cup to use? And but in America, they have standard measurement that represent a cup, pint, quarts. So are you using mil or liter? Another one I found very, very challenging in the common measurements I wrote out here is the degrees. So I read a lot of protocol and they say it was measured at 30 degrees. They end with degrees. Degrees what? Is it degree centigrade or Fahrenheit? And meanwhile, when American tells you is a Fahrenheit, because they use Fahrenheit, if they tell you it's Fahrenheit and we're using centigrade, you may be rejoicing that the temperature is good. If they say, for example, 98.6 degrees Fahrenheit, it's not very high. It's our room temperature here, which is like 37 degrees centigrade. So we need to complete, instead of writing degrees, whether it's centigrade or Celsius or Fahrenheit, we need to do that. So pressure, volume, energy reporting, we have to comply. So you see what happened to these policymakers. They ask, how did we get here hiring a cat? So that what it can cost when we do not standardize. So you can end up hiring a cat to be among humans. So that shows silly mistakes that can be disastrous. So like this little girl that I've been told her regular ice cream is not good, which is the conclusion. Our recommendation is that she should start eating more greens, broccoli. We may not be comfortable with that conclusion. There are a lot of inconsistencies in our scientific writing. So we should begin to think about consistency as it will enhance global research collaboration, and international bodies play a crucial role. We do not want to follow them. So I want us to follow them to get updates on terminologies, on units of measurement, and we should adopt standardized terminology in our research groups, in our universities, in our research institutions, in our industries, in our country, in science. Yeah, we should do that. And we should promote awareness. Many of our peers are not aware about standardization. A lot of people ask me, what is it about? When they saw the flyer, they do not know about standardization. So educate not only students, but colleagues, because colleagues also do not know. Sometimes we abandon experiments because we do not know how to measure because of the unit that have been placed there. So follow best practices like we have mentioned, use style guides. So many serious people use style guide. They develop there, so any employee, new employee, or somebody that comes into your research group should be introduced to your style guide so they can follow suit. Use reference management tool and engage with standardization bodies. I've said that to get updated and latest guidelines. If we do this, I think we'll be better for it. That's it. Thank you.
Take one or two questions. Is it possible now to have common ground, such as in units and measurement? I also discovered that in so many places, Prof said there's need to standardize, the organization needs to put things together. Maybe that is what has provoked this question.
We are guided by the standard organization, because if everybody is developing theirs, we can make a headway, because you can imagine a food cooked by many cooks, it will be crazy. So we believe in them because they have got reputation, and before they can get registered globally, you know, they pass through a lot of QA, QC measures. So we believe in them. If we follow them, we can comment. They can take into cognizance of our comments, of our concerns. And in the next revision, if they need to do, they can consider that. But America is not going to cave into the British style. But then when their audience in international collaboration, they agree to write using the global metrics. Yeah, okay. So the audience in mind, always, let's serve the audience in the best way we can.
Thank you very much, Prof.
Mine is not really a question, but a kind of observation that could also be part of the takeaway. The presentation has also, to me, open out the fact that we need to harmonize, we need to standardize a lot of things. You can imagine having a project, like Prof said, and you're doing a research and you get to the middle of the road because of measurement, and then everything is run aground. It is important to pay attention to this standardization. Otherwise, no matter how the network and the number of researchers we have, if common standardization of measurement issues can drop us, then we need to work about it. It's a serious thing for the national policy development in every sector, right from agriculture, nutrition, manufacturing, even to the extent of policing and strategic communication. Measurement is very important. Thank you very much for this presentation.
Prof, you like to react to?
I agree seriously with him, because I imagine where we have collaboration, maybe from AB Eucharia, University of Port Harcourt, and maybe OAU, and maybe we divide the work, according to milestones. Maybe the first milestone is to determine the volume of something to be used, and then submit that to the next team. So if I don't consider standardization and I give a wrong value, they take off from there, and then they feed the other group. They take off from there, and everything is wrong. So you can imagine the waste all through the time we spent forming the team, training the team, writing and winning the grant, and then the organization that's funded everybody. If we publish people who have used it world over, the damage is unimaginable.
Thank God our guest speaker for today is an environmental scientist. In some cases, there are some new topics that are not standardized yet. example is microplastics. I happen to work on this particular area during my PhD, and I see a lot of units that are very difficult to convert and use one. So please, what's your advice in new areas like this that are yet to standardize?
In these new areas, I think that we will go from somewhere to new areas, open up from somewhere. So we go from the older units where we're coming from, and we will declare it's always good to declare that the unit of measurement for XYZ was.
I have a takeaway. For me, the most important thing that I got from here is that I think I will be one of those that will not say measurement is common. We'll say common measurement and common standardization and common units. No, they are not common. Especially when I look at the pictures painted in the beginning of the lecture with respect to the different disasters that has happened as a result of measurement. For me, that is the most important takeaway. I don't know if most of you will agree with me. And because of that, I want to plead to all of us here to please share this link, not because of Researchment Academy, but because of our teaming scientists who need this information. Let us share it to them because it's already uploaded on the YouTube so that they can benefit immensely from it. I think you will have done a lot of favor to a colleague or a community of colleagues by sharing the link to this presentation of today to them. We can see the flow. That example from the beginning is a serious motivation for me. And I think for those of us who were here from the beginning, you agree with me that that is very, very important. And we need to communicate it to others so that they can benefit.